Good day, Chargers. Mrs. Boyd here. Today we're going to talk about the quadratic formula and the discriminant. This is not something that you have not seen before. You should be really familiar with this equation, but we're going to do a lot of practice anyways. The quadratic formula itself is something you can use to factor and solve any and all quadratic formula, period. So if you remember nothing else about how to factor or solve quadratic equations, you can always fall back and rely on the quadratic formula, which is, as is shown here, it is, all right, it is x equals negative b plus or minus b squared, the square root of b squared minus 4ac, all divided by 2a. Has a little song. Let me sing it for you. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Ta-da! You're never going to forget. You're welcome. Let's get into it. So, number one, x squared minus 10x equals 11. First and foremost, these always have to be set up in standard form where they're equal to 0. So first, we're going to subtract 11 from each side so that our equation is equal to 0. I've got x squared minus 10x minus 11 equals 0. Now, that means a, the number in front of x squared is 1, b, the number in front of x is negative 10, and c, the number all by itself is negative 11. We're going to fill what we know into the equation above. So we've got x equals negative b, negative 10, plus or minus the square root of b squared, which is negative 10 squared, minus 4 times 1 times negative 11, all over 2 times a. Let's do some simplification. First, we can get rid of these double negatives. So I've got 10, not negative 10, plus or minus the square root of negative 10 squared is 100. Negative 4 times 1 times negative 11, excuse me, is plus 44. Yes, that's a 4 and a 4. And that's all over 2. Let's simplify under the radical. X equals 10 plus or minus the square root of 144 all over 2. Well, 144 is a perfect square. So we've got x equals 10 plus or minus 12 all over 2. Now, this is two values. One of them is x equals 10 plus 12 over 2. And the other one is 10 minus 12 over 2. 10 plus 12 is 22 over 2 is 11. 10 minus 12 is negative 2 over 2 is negative 1. So your solution is going to be x equals 11 comma negative 1. Show it all in one equation here with a comma separating your values. Got it? Fantastic. Let's do one more together. Number 2, I get x squared plus 6x equals 16. Same idea. We're going to subtract 16 from each side. And I've got x squared plus 6x minus 16 is 0. That means A is 1, B is 6, and C is negative 16. Fill in our equation. X equals negative b, negative 6, plus or minus the square root of b squared, 6 squared minus 4 times a times c, all over 2a. Let's simplify a bit. Negative 6 plus or minus 36. And then 4 times negative 1, negative 4 times 1 times negative 16 is plus 64. And that's all over 2. Well, 36 plus 64 is 128. So that's x equals -6 plus or minus square root of 128 all over 2. Now, 128 is not a perfect square, so we'll have to simplify. Something we can divide 128 by. Well, we know 2. So 128, I've got 2 and 64. 64 is a perfect square. That's 8 times 8. That's a pair, right? 2's left. So this is going to be -6 plus or minus 8 times the square root of 2 over 2. I can simplify just a smidge more. -6, 8, and 2 are all divisible by 2. So this is going to become x equals -3 plus or minus 4 times the square root of 2. And that's your answer. You don't have to simplify any further than that and write it separately. Won't do you any good. As long as you get all the signs right, which is tough on here, then we're going to call it a day. Okay, I think you're ready to fly on your own here, kids. Try the next one on your own, please and thank you. Pause here, make it happen. All right, we don't have to rearrange this one. It's already set up for you. So we've got A equals 1, B is -16, C is 64. X equals -16 plus or minus the square root of b squared, -16 squared, minus 4 times 1 times 64, all over 2 times 1. We can simplify. Sorry, that was such a strange angle there. 16 plus or minus the square root, 16 squared. That's one I don't know off the top of my head. Oh, I do actually know. 256. And then 64 times -4 is -256. And that's all over 2. So if we simplify just a little bit more, we get 16 plus or minus the square root of 0 over 2. The square root of 0 is 0. So this turns into 16 over 2, or 8. So our solution is x equals 8. Hallelujah, we did it. Do the next one. You can totally do it. All right, don't have to rearrange. You get A is 1, B is -8, C is 9. Put it in our equation. -b, I forgot x equals, -b plus or minus the square root of b squared minus 4 times A times C all over 2A. So that is x equals 8 plus or minus the square root of 64 minus 36 all over 2. 64 minus 36, that's 8 plus or minus the square root of 28 over 2. Well, I can simplify 28. It's 7 and 4 is a perfect square. So this becomes 8 plus or minus 2 times the square root of 7 over 2. We simplify just a bit more and get 4 plus or minus the square root of 7 as our answer. So x equals 4 plus or minus the square root of 7. All right, last one is all yours. Do it. All right, we can do it. I have to rearrange this one. So we add 10 and add 10. We get x squared minus 6x plus 10 is 0. Sorry, the last problem kind of encroached on our space. A is 1, B is -6, C is 10. So we get x equals -b plus or minus the square root. I'm going to go ahead and square b minus 4 times A times C all over 2a. That becomes 6 plus or minus 36 minus 40 over 2. That then becomes 6 plus or minus the square root of negative 4 over 2. Well, we can make negative 4 I and 2 and 2. So when we rewrite this, x equals 6 plus or minus 2i over 2. I can divide everything by 2 and I get 3 plus or minus I for my answer. So x equals 3 plus or minus I. Fantastic. Hope you understood so far. We're going to move on to something else. The expression b squared minus 4ac is called the discriminant. The value of the discriminant will help you determine the number and type of possible roots. I don't know why there's all this room here. Hopefully I fixed it on your notes. If our discriminant is greater than 0 and a perfect square, there are 2 real rational roots. Okay, this is important. It has to be a perfect square for 2 real rational roots. If it's greater than 0 and not a perfect square, there are 2 real irrational roots, which means I'm going to have a radical in my answer. If it's equal to 0, there's 1 real rational root. Just like we saw above, when your radical is 0, you just get 1 answer, and it's real. If it's less than 0, there's 2 complex roots, meaning we're going to have an I, because you're going to have a negative radical. Let's do just a couple of these, and then you'll be on your own. All right, so A is 7, B is negative 11, C is 5. We're just finding the discriminant. So I want B squared, negative 11 squared, minus 4 times A times C. Negative 11 squared is 121, minus 4 times 7 times 5 is 140. Well, 121 minus 140 is negative 18. So that's my discriminant, negative 18. So I'm going to have 2 complex roots. Pretty straightforward, right? It's a great way to test and see if your answer is correct and to get a roundabout guesstimation at what your answer will be. Try this last one on your very own. You can do it. Ready, set, go. All right, I get A is 1, B is 22, and C is 121. I see the discriminant. B squared, 22 squared, minus 4 times A times C. So 22 squared is 484 minus 4 times 1 times 121 is 484. So my discriminant is 0. And if you look above, when your discriminant is equal to 0, you'll have 1 real rational root. Hallelujah, we totally did it. All right, good luck. Let me know if you have any questions. I know you can do it. Bye-bye.